Let's do some sums. Before starting, let me review one more time. For doing probability formula sum in S1, we need this formula for union. A union B probability is probability of A plus probability of B minus probability of A intersection B. For conditional probability, we need probability of A conditional B is equals to probability of A intersection B divided by probability of B. There is one more rule, basic rule, probability of A prime is equals to 1 minus probability of A. For Venn diagram, when you have to find probability of A intersection B prime, then you remember A intersection B prime means removing B from A. This portion is what you're looking for, and that can be found using basic area. Then for probability of B intersection A prime, that means removing A from B. And for finding A prime intersection B prime, you have to find this region. So that's it, that's all you need. And you need the two rules of independent probability. Independent, that means probability of A intersection B must be equals to probability of A multiplied by the probability of B. And mutually exclusive, probability of A intersection B must be equals to 0. So let's get started. The first question is given events A and B such that probability of A is 2 by 5, probability of B is 1 by 2. Probability of A is 2 by 5, probability of B is 1 by 2, and the information given here is probability of A conditional B prime is 4 by 5. The first question, find probability of A intersection B prime. So this is question number A1. Find the probability of A intersection B prime. Now remember, A intersection B prime, we should use the Venn diagram. We cannot use the formula because the formula is for union and conditional probability. We have to use the Venn diagram. So first take a look at the Venn diagram, A intersection B prime. For finding A intersection B prime, what we can do here is we can take the probability of A, and from that we can subtract A intersection B, or we can take the probability of A union B and we can subtract the probability of B. So that will give us probability of A intersection B prime. So that is the first instinct, to look at the Venn diagram. But here we do not have A intersection B, we do not have probability of A union B to find this. So the next thing that we have to do is go to the formula. So the formula here is for conditional probability. Now the conditional probabilities formula is A conditional, the first conditional, the next one is intersection between the two divided by the second one. So we can write, therefore probability of A conditional B prime is the first one intersection the second one divided by the second one. Now we know that A conditional B prime is 4 by 5, so let me plug in here 4 by 5, and we have to find probability of A intersection B prime. Now B prime is needed. We know the probability of B is half, so the probability of B prime is going to be 1 minus B, meaning 1 minus half, so 1 minus half. 1 minus half is half, so if you cross multiply, this would be 4 by 5 multiplied by 1 by 2 equals to probability of A intersection B prime. So if we cancel this and this, so therefore probability of A intersection B prime is going to be 2 by 5. The next one is find the probability of A intersection B. So let's do it here, probability of A intersection B. In the previous sum we found probability of A intersection B prime, which is 2 by 5. So A intersection B prime is this portion. This is what we found. Now remember, we can use the formula if it is union or if it is conditional. These are the two formulas that we can use. This is a site formula. So A intersection B prime A intersection B, we have to take the help of the previous sum. So in the previous sum we found A intersection B prime, and A intersection B prime refers to the Venn diagram. Always remember, A intersection B prime, B intersection A prime intersection B prime refers to the Venn diagram. So for doing this sum we need to use the Venn diagram. So we know from the Venn diagram A intersection B prime is going to be probability of A minus probability of A intersection B. So from the circle A, from the set A, if you remove this intersection portion, then you're going to get A intersection B prime. So we know A intersection B prime is 2 by 5 equals to, we know probability of A is going to be also 2 by 5 minus, we have to find the probability of A intersection B. So therefore probability of A intersection B, I'm taking this to this side, equals to 2 by 5 minus 2 by 5, and it's going to be 0. So that means A intersection B is going to be 0. In other words, it is mutually exclusive. Question number 3 is A union B. We can directly use the formula. So the formula for A union B is probability of A plus probability of B minus probability of A intersection B. So probability of A is 2 by 5, probability of B is half. So if you subtract the intersection, which is 0, so by doing this calculation it will be 2 by 5 plus 1 by 2, 1, 2. So the probability would be 9 by 10. In number 4 we have to find A conditional B. So we have the formula for A conditional B. Probability of A conditional B is equals to the first one intersection the second one divided by the second probability. Since we've previously found the probability of A intersection B is 0, it will be 0 divided by B. So probability of B is 1 by 2. So 1 by 2, so 0 divided by anything is 0. So A conditional B is going to be 0. Now we have to state with a reason whether or not A and B are mutually exclusive. Number 1. So B1 is going to be, question number B1, since probability of A intersection of probability of B equals to 0, we can say A and B are mutually exclusive. We know the condition that mutually exclusive probability means the intersection has to be 0. Number 2, we have to show that A intersection B is independent or not. So you know the rule, if they're independent, that A intersection B should be equals to A into B. So we know probability of A intersection B is equals to 0, and probability of A multiplied by probability of B is 2 by 5 multiplied by half, which is 1 by 5. So we can write, since probability of A intersection B is not equal to, we can write it like this, and equal to sign with a slash, is not equals to probability of A into probability of B, they are not independent. So that's how the whole thing works. The next question, question number 2, there are 3 events A, B and C, and we have the sample space S, just a fancy way of mentioning sample space, it's just the universal set. It is given that A and B are mutually exclusive and A and C are independent. Draw a Venn diagram to illustrate the relationship between the 3 events. Now when we are talking about independent probabilities, they can be expressed in a Venn diagram like this. If 2 events are independent, they look like this, they intersect. Remember, even independent probabilities can have the same probabilities, there is no problem at all. As long as one is not affecting the other, they can have the same outcome. Mutually exclusive probabilities, on the other hand, will never intersect because the intersection is 0. So for mutually exclusive probabilities, the intersection is going to be 0. So A is going to be here and B is going to be here. So this is what it looks like. What we have to do in this particular sum in question number 2 is we have to draw the Venn diagram where the relationship between A and B are mutually exclusive. So that means if it is A and this is B, A and B are mutually exclusive. Now, since A and B are mutually exclusive and A and C are independent, now what about C? Now C can be like this. So A and C are independent means they will intersect. That would make C and B mutually exclusive too. But they didn't mention anything. So let's do one thing. Let's write it like this. A and C are independent and A and B are mutually exclusive. So that doesn't mean that B and C are mutually exclusive. Maybe B and C are independent as well. So we are taking the benefit of the doubt. We could have also drawn this like A and B mutually exclusive and A and C independent. We don't worry about whether B and C are mutually exclusive or independent. So we're just drawing this version. Both the version should be correct. So this is just a Venn diagram where we show that A and B are mutually exclusive, they do not intersect, and A and C intersect. The information given here is probability of A is 0.2, probability of B is 0.4, and probability of A union C is 0.7. So let's write this down. Probability of A is 0.2, probability of B is 0.4, and probability of A union B is 0.7. The first question, find A conditional B. Very easily done with a formula. Probability of A conditional B. A conditional C. A conditional C formula is A intersection C, intersection of the first one and the second one, divided by probability of the second one. So we know that probability of A intersection C is not given here. So we know A and C, they are independent. So we can write probability of A multiplied by probability of C. You have to remember they have mentioned that A and C are independent. Independent means we need to multiply. And probability of C is going to be this. So this and this cancels. So it is going to be probability of A, which is 0.2. Remember, we know now which is independent and which is mutually exclusive. We have to use that concept. B2. This is not B2, this is number C. A union B. So A union B is going to be using the formula. Probability of A union B is going to be probability of A plus probability of B minus probability of A intersection B. Now probability of A is 0.2, probability of B is 0.4 minus, now remember this is independent. A and B are independent or are they mutually exclusive? A and B are mutually exclusive. So remember, A and B are mutually exclusive. That means the probability of A and B is 0. A intersection B is going to be 0. Remember, that's the rule for mutually exclusive probability. So whenever they give you the information, you just plug it in. So the probability of A union B is going to be 0.6. Question number D says, find the probability of C. So we have to find the probability of C. For finding the probability of C, we can use the formula or we can use the Venn diagram. So in order to do that, it's a decision that I'm not sure about what to do. So I always prefer the formula over the Venn diagram. So in question number D, I would prefer to use the formula for A union C. So A union C is equals to probability of A plus probability of C minus probability of A intersection probability of C. So probability of A union C, we know it's 0.7. This is C, A union C. So this is 0.7. So we just plug it in here. This is 0.7. Probability of A, we know it's 0.2. Probability of C, I do not know. So let me write probability of C. minus probability of A intersection C. Now A and C are independent. It is mentioned in the question that A and C are independent. Remember this is very important. So probability of A intersection C is going to be probability of A, which is 0.2, into probability of C, which is unknown. So what we can do here now, we can send the 0.2 to the other side. It would be 0.7 minus 0.2, which would be 0.5, equals to, now here probability of C minus 0.2 probability of C. If I take probability of C common, it would be 1 minus 0.2. So this would be 0.5 equals to 1 minus 0.2 is 0.8, so 0.8 probability of C. Therefore probability of C is 0.5 divided by 0.8, which will be 5 by 8. So the probability of C is 5 by 8. Question number 3 is also that A and B are independent events. Probability of A is 0.25, probability of B is 0.3. So for this particular sum, question number 3, we know probability of A is 0.25, probability of B is 0.3, and we know probability of A and probability of B intersection is going to be probability of A times the probability of B, because they are independent. The first question is find A intersection B. So probability of A intersection B is going to be, since they are independent, probability of A multiplied by the probability of B. 0.25 multiplied by 0.3 is going to be 0.075. Question number B. Find A union B. A union B means formula is preferable. So A union B is going to be probability of A plus probability of B minus probability of A intersection probability of B. Probability of A is 0.25, probability of B is 0.3 minus 0.075. So let's bring out the calculator. .25 plus 0.3 minus 0.075. That would be 0.475. 0.475. Question C is A conditional B prime. The formula would be used. A conditional B prime means probability of the first one intersection the second one, A intersection B prime, divided by probability of B prime. So since A intersection B prime, we prefer the Venn diagram, and you remember that the Venn diagram looks something like this. A intersection B prime is this one. From A remove the B, and by geometric area we can say, so probability of from A, we can write probability of A subtract probability of A intersection B. So if you, from the circle of A, if you remove the intersection portion, you'll get this. So we can easily write probability of A minus probability of A intersection B. So this one is that one, divided by probability of B prime. B prime means 1 minus probability of B. So let's plug in the values. Probability of A is 0.25 minus probability of A intersection B is 0.075 divided by 1 minus probability of B is 0.3. So we can calculate 0.25 minus 0.075 is going to be 0.175 divided by 1 minus 0.3 is going to be 0.7. So 0.25. Probability of A conditional B prime is 0.25. Question number 4 starts with some basic definition of probability. The first definition is, what is sample space? Sample space refers to the population, meaning all the possible outcomes. Question number 4. A sample space all the possible outcome of a probability experiment. When you do a probability activity, it is called an experiment. In B, the definition of event is a specific outcome from all the possible outcomes. So, a specific outcome from the sample space. That's the definition of an event. Gets back to the sum. Again, they're mentioning two events are independent. So probability of A is 1 by 3, probability of B is 1 by 4. So for doing C, it is given probability of A is 1 by 3, probability of B is 1 by 4, and A and B are independent. So we have to find A intersection B. A intersection B can be found using the independent formula straight away. Probability of A intersection B is equals to probability of A multiplied by probability of B. That means it will be 1 by 3 multiplied by 1 by 4, which means 1 by 12. The next one is probability of A conditional B. Probability of A conditional B is done using the formula that probability of A conditional B is probability of the first one intersection the second one divided by the second one. So we know that the probability of A intersection B is 1 by 12. We found it in the previous sum. We also know that the probability of B is 1 by 4. So 1 by 12 divided by 1 by 4 is supposed to be 12 multiplied by 4 is 1 by 48. No, it will not be 1 by 48. It would be 1 by 3 because 1 by 12 into 4 is going to be 1 by 3. The next one is, let's A union B. A union B can be done by the simple formula. So for E, we can do probability of A union B is the formula of probability of A plus probability of B minus probability of A intersection B. Probability of A is 1 by 3 plus probability of B is 1 by 4 minus probability of A intersection B is 1 by 12. So using the calculator, we can find out one by 3 plus 1 by 4 minus 1 by 12 is half. So probability of A union B is half. Let's do one last sum. The events A and B are such that probability of A and probability of B is 1 by 2, 1 by 3, and probability of A intersection B is 1 by 4. So probability of A is 1 by 2, probability of B is 1 by 3, probability of A intersection B is 1 by 4. Use the space below represented these probabilities in a Venn diagram. So we have to represent this probability in a Venn diagram. So this is a pretty straightforward sum. So we have this. We don't know whether they're independent or mutually exclusive, so we can assume they're independent. So they intersect. This is the universal set symbol. So if A intersection B is 1 by 4 and this entire circle is half, so then this region should be 1 by 4 minus half. So 1 by 4, half minus 1 by 4, half minus 1 by 4 is 1 by 4, though this region is 1 by 4. Remember, this entire circle is half, that represents A, and the intersection is 1 by 4. So if you want to find this region, you should, from the entire circle A, you have to subtract the intersection, then you will get this region, which is A intersection B prime. Now this region, again, from the entire B 1 by 3, you have to subtract 1 by 4. So that is going to be 1 by 3 minus 1 by 4. That would be 1 by 12. So this is 1 by 12. Now we need to know one more thing, outside region. This region is from the entire probability. That means we want to know from the entire probability, if we subtract this region, what is left over. So from the entire probability 1, if we subtract 1 by 4, if we subtract 1 by 4, if we subtract 1 by 12, then we get 5 by 12. So the remaining region should be 5 by 12. So the first question that we have to do is find A union B. A union B is going to be probability of A union B is equals to probability of A plus probability of B plus minus probability of A intersection B. Probability of A is 1 by 2, probability of B is 1 by 3, and probability of A intersection B is 1 by 4. So by calculating this, 1 by 2 plus 1 by 3 minus 1 by 4 is going to be 7 by 12. Now we have to find A intersection B prime. So probability of A conditional B prime is going to be the first one intersection the second one divided by the second one. Now from the Venn diagram, we know A intersection B prime is this region. This region is A intersection B prime. From A, remove the intersection. So this is 1 by 4 directly we can use from the Venn diagram. And B prime, it's outside the B circle. So outside the B circle, or 1 minus B, is going to be 1 minus 1 by 3. So which is going to be 1 by 4 divided by 2 by 3, which is going to be 1 by 4 divided by 2 by 3, 3 by 8. So I hope you have an idea of the type of probability formula sum that would be given in the S1 exam.